another episode of Math with Mel. With me. And her! We're not going to beat it all.
Okay. Thank you for the intro, children.
We're
All right.
the best.
6.5 is again same as last year's lesson, except for we're changing it to radians. So, remember all the questions we did in... don't bounce because it shakes the...
Oh.
All the lessons that we did in Trig 2 where we were doing tide problems and Ferris wheel problems. It was basically applications. I think in grade 11 we called it applications of trig functions. This is going to be the exact same, but we just changed it to radians. So it's still going to be tide and Ferris wheel problems. A couple pendulum problems, but similar in nature. So the note has 2 tide problems. I want to do 1 tide problem and 1 Ferris wheel problem. So you will remember, this is still review from 6.4. Guys, if you're going to be distracting.
I'm not distracting, right? Ben's not passing to me.
Then I don't want to do it with you. Both go up.
Fine, I'll stay here. Ben, pass the thingy.
Okay, stop talking. Okay, so we want to write them always in terms of sine and cosine. Those are the 2 functions we're going to use. And again, we have an A, B, C, and D value. So all of these values other than the C value can be found by using a formula, which makes life quite a bit easier. So I went over these in the last section. I want to go over them again. The amplitude or the A value can be found by doing half the max minus the min. So in a problem that's typical of a tide or Ferris wheel problem, they give you like a max height of the tide or a max height that the Ferris wheel gets to, a minimum height, a minimum tide height. So that is information that's given that will allow you to come up with an A value right away. The B value is going to come up, again, be 2 pi divided by the period. The period in this case is almost always an amount of time, or like how much time it takes to do 1 revolution of a Ferris wheel, or how much time it takes for 1 tidal cycle. So we'll substitute that in and get a B value. The D value, which is telling you how much the whole thing has been shifted up or down, is going to be by finding the average of the max and the min. So add the max and min, divide by 2. And then the C value, you'll sort of have to figure out based on whether you're doing a sine or a cosine curve, and it's more done through inspection. So we'll keep this sort of thing in mind while we do the examples. Okay, the 2 examples that I want to work on are example 2 in the note, and then I'm just going to pick a random Ferris wheel one to go over with you so that you know what you're doing on those. So example 1 is fine. It's just a little bit easier. So with the nature of time, you can, if you want, watch Mr. Todd's video and you can see all the examples worked out. I'm just trying to curtail it to the more important ones that you're going to see more often in the note. So example 2, and this is actually the exact same question as the lesson from grade 11. We're just going to answer it with radians instead of degrees. So it talks about a tide that says the water depth is 21 meters at high tide.
Okay. I'm learning something.
Okay. 11 meters at low tide. And 1 cycle is completed every 12 hours. So that becomes our period.
How long is a meter? Oh, okay.
Okay, so the period, Morgan. Guys, if you want to stay out here, you have to not be like that. Okay, so a period of 12 hours means you get a high tide and a low tide. That's what we're considering a tidal cycle here. So find an equation for water depth D as a function of time. So we're trying to find D of T. So instead of using X's and Y's, we're really using D's and T's. So when we look at the general equation, how we know it, pick sine or cosine. What's the problem?
Nothing. We're just
Okay. When we talk about this, because they want the answer to be in terms of depth and time, we're going to change our Y to a D and change our X to a T. When we do that, it's just a matter of, can we find an A value, a B value, a C value, a D value, and if so, can we substitute them in to get a logical answer? Can you stop being pests, please? Okay, I'm going to kick you out.
Oh, we're not doing anything.
Okay, so the A value is sort of the easiest, half the max minus the min. So when we think about water depth, this is the maximum water depth is 21 meters, the minimum water depth is 11. So the amplitude becomes half of 21 minus 11. Half of 10, which is 5.
Half of 11?
So we've already found our A value. Our B value is going to be 2 pi divided by the period, we learned that the period is
10
12 hours.
I was
So
close.
our b value will be pi over 6.
Shut up.
Okay, so that has been calculated. C value, we're going to hold off for a moment. Our D value is half of the max plus the min, which is half of 21 plus 11. So this is basically trying to tell you how much the whole graph has been shifted up. Remember we drew that kind of horizontal D line? Well, when I add 21 and 11, I get 32. Half of that is 16. That's the number right between 11 and 21, and that's sort of like our basic, we call it like a rest axis that it fluctuates on. So just by doing this, we have calculated A, B, and D without putting any thought into it. You have the formulas, so once you have the formulas, it's really a matter of substituting them in. So this one doesn't give us a specific thing. It doesn't say we have to start at high tide or low tide, I don't think. Let me just check. Find the equation after low tide. Oh, it does say after low tide. So. So something to be aware of, if you're going after low tide.
Mommy,
What?
can I do one quick thing?
Sure.
And this is what you need to stay your whole life with. Paper towels. You're such a dummy.
Okay, so we found out that our D value is 16, so that's sort of like a rest axis up here. Now we want to graph
Shut
it
your
in such a way that we start at low tide. So if we start at low tide, we're going to go like this. So we need to come up with an equation where we are starting at low tide. So we've already identified these sort of things. The A value is 5. We don't know whether we want sine or cosine right now, but as you can see, this is a natural cosine graph that's been reflected. So that's one option. So let's do both. Let's come up with a sine equation, and let's come up with a cosine equation. Now, the cosine one, I can already see as a reflection here. So, do I have a B value? Yes. Pi over 6.
Pi over 6.
Pi over 6.
up.
More, Ben, watch your language. D value of 16.
D value.
Okay, so I know those D values are 16. The matter of fact is I have to now come up with a C value. C value talks about how much has been shifted left and right. So a couple things to be aware of.
Somebody texted you.
I don't care, Morgan. A couple things to
It
be
says
aware of.
text message.
Great. If this is 16 here,
Step down.
and we start at low tide and we go across, how do we figure out what the tick marks are going across here? Well, we know there's one tidal cycle in 12 hours. Well, remember how we found the, what did we call it? Losing my mind. We found, the intervals that we had to do by dividing by 4. So really what we're looking at here is 3, 6, and 9. Because if you take 12 and you divide by 4, you get 3. So it goes up 3, 6, 9. So as a cosine function, this is a natural cosine function that's been reflected. That's why I put a negative there. There is no phase shift. But for sine, if you want to do this as a sine function, sine would naturally start right here. And then we'll go up and down, up and down, up and down. So this has been shifted 3 units to the right. So if you were going to put that in here, you'd have to have t minus 3. Okay? So the A value, the B value, and the D value can all be calculated with simple, quick formulas. The C value has to be inspected. So if you actually draw the graph, you can say, okay, it's been shifted 3 to the right. Or when you draw the graph, you can say this isn't actually a reflection. Okay? Both of these are correct. It's not one or the other. But that's the basics sort of in how you do a tide problem. A lot of it, I mean, you can get 3 out of 4 on this question just by plugging in the numbers into the formula. And then really the only other thing you have to do is sort of inspect to find the C value. So it's not overly difficult. Again, it's exactly the same as grade 11 other than I left this as 2 pi instead of 360. Same question though. Okay, so take a look, even if you still have your notes from grade 11 to see how we did that. Now the other one I want to do is a Ferris wheel problem. There are a few of them in the homework. And it's the same sort of idea. Like once you know how to do one Ferris wheel problem, you know how to do all of them. So I see one in the homework here has a something is revolving somewhat like, I think it's a hamster wheel question. So it looks like number 11 on page 345. Now, I don't have the textbook out here, so I can't really tell you the situation, but I think it's a hamster wheel question. So basically they're saying, here's a hamster wheel. Okay, so get the idea. The hamster goes in, run, 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 run. Now, it must tell you there's one revolution every 3 seconds. That's information that's given in. So if the hamster starts running, it goes every 3 seconds, the same spot on the hamster wheel will come back. Okay, it also says the hamster wheel is 2 centimeters off the ground. Okay, so that's 2 centimeters. And that the hamster wheel is 50 centimeters in diameter. So this distance here is 50 centimeters. Okay, and that's all the information that's given, and you have to come up with an equation for that. So there's a couple of things you sort of have to ask. If you were going to fixate this into a graph, say, and maybe that's the important part. First of all, one revolution every 3 seconds. One revolution is what we consider the period, right? One cycle is the period. So we know that this has a period of 3 seconds. Okay, which means we want to get one thing in by 3. Okay, now we want to split this up into 4. That's not so important right now. But when we're graphing this, first of all, if you're going to open the door and put the hamster in, he comes in at this part right here, which is 2 centimeters from the bottom. The hamster goes in, the thing rotates and returns back to the same spot. Imagine if this was a Ferris wheel. You would step into the Ferris wheel at the halfway point, wherever halfway is 1.5 seconds, you'd be at the top of the Ferris wheel. Another 1.5 seconds goes by and you're back at the bottom. So this is one cycle. The question is, what's the max height you reach? Okay, we know the minimum height is 2 centimeters because here's the ground, you're 2 centimeters above. To reach the max height, not only are you 2 centimeters above, but you also have to go through the entire diameter of 50. So you're getting up to a max height of 52. Okay, so that's a couple things to be aware of. From there, you should be able to start kind of coming up with all the values you want to come up with. So some of them are much more straightforward. So do the 3 that are really easy. Amplitude is always half the max minus the min. Of course, okay, half max minus the min. Well, we've now discovered what our max is. Our max is 52. Our minimum is 2. 52 minus 2 is 50. Half of that is 25. Great, I have my A value. Okay, B is 2 pi over the period. In this case, the period is 3. So our B value is 2 pi over 3. Our D value is half the max plus the min. And remember, you're trying to find that magic value that's right in between 2 and 52. That says how much this graph has been shifted up. Otherwise, the graph always fluctuates around the axis, right? So this is called a rest axis where you shift it up to. So you do half of 52 plus 2, and you get 27. So this magic number here is actually 27. And that's how much your whole graph has been shifted up. So now, when you're trying to come up with what does this look like, you have a couple choices. Does it look like a natural sine graph or a natural cosine graph? And it's really up to you. On a question like this, you're not being told whether to make it sine or cosine. So to me, naturally, it looks like a cosine graph that's been reflected. So my first thing would be, if I was coming up with this and using the formula A sine cosine B x minus c plus d, I would say my A value is 25. When I look at this, I think it's a cosine graph that has been vertically reflected. So I would put a negative out there. My B value is 2 pi over 3 times x. And I don't have a C value because that's natural. plus my D value of 27. And that's how I would do that one. You could make it a sine graph, and then you would just need to know that this is 0.75 seconds. So it's been shifted right 0.75. That one's 2.25, but it's really up to you. So just be aware, it helps to draw a sketch for a Ferris wheel question. It's not a requirement. It's kind of up to you how you want to do it. But for sure, that makes life a little bit easier. Use these formulas, pump them in. Shouldn't be a problem. Sorry about my children. They have been craving attention.